Ever pondered over the question of how stars, those twinkling lights in the night sky, get their energy? Welcome, cosmic explorers! Our celestial journey today takes us deep into the universe to uncover the secrets of the stars. Imagine gazing up at the night sky, the stars shimmering like diamonds scattered on a black velvet canvas. Have you ever wondered how these celestial bodies, so far away, shine so brightly? The answer to this burning question lies in the heart of the star itself. It's there, in the star's core, where an extraordinary process occurs. This process, a series of nuclear reactions, is responsible for the star's radiant energy. It's the cosmic kitchen, where elements are cooked under extreme temperatures and pressures, giving birth to energy that lights up the universe. This is no simple process, but a fascinating dance of particles, a ballet of nuclear reactions that fuels the stars. Today, we delve deep into the heart of a star to uncover this cosmic mystery. Imagine a star as a gigantic kitchen where the primary ingredient is hydrogen. Much like a kitchen, stars are a place of transformation and creation, where raw materials are converted into something new and exciting. Stars, these celestial bodies that appear as tiny twinkling dots in our night sky, are primarily composed of hydrogen and helium. These elements make up over 90% of a star's composition, with hydrogen being the most abundant. Now, why hydrogen, you ask? Well, hydrogen is the lightest and simplest element in the universe. It's like the flour in our kitchen analogy, providing the base for everything else. But for a star, hydrogen is more than just a base. It's the fuel that keeps it burning bright. Stars are not just composed of hydrogen and helium, though. They are also vast pressure cookers, with the core of a star experiencing immense pressure and temperature. The core is the heart of the star, where the real magic happens. It's like the stove in our kitchen, where the ingredients come together to create something delicious. In the core of a star, the conditions are just right for nuclear reactions to take place. The high pressure and temperature cause the hydrogen atoms to come together in a process called nuclear fusion. These atoms combine to form helium, and in the process, a large amount of energy is released. This energy is what powers the star, causing it to shine brightly in the sky. But it's not just about the energy. The process of nuclear fusion also leads to the creation of heavier elements, much like how different ingredients in a kitchen come together to create a variety of dishes. These elements are then expelled out into the universe when the star reaches the end of its life, providing the building blocks for new stars, planets, and even life itself. In this stellar kitchen, the recipe for energy is cooked up. So the next time you look up at the stars, remember, you're not just seeing a beautiful night sky, you're witnessing a cosmic kitchen at work, cooking up the energy that powers the universe. The main dish cooked in our stellar kitchen is the fusion reaction. Now, if you're wondering what a fusion reaction is, let's break it down. It's a kind of nuclear reaction where two or more atomic nuclei collide at a very high speed and join to form a new type of atomic nucleus. Stars like our Sun conduct this process on a grand scale, and the results are nothing short of spectacular. So, how does this fusion reaction take place? Imagine a stellar kitchen bustling with ingredients. The main ingredient here is hydrogen, the lightest and most abundant element in the universe. In the heart of a star, where temperatures reach millions of degrees, 4 hydrogen nuclei come together in a series of steps to form a single helium nucleus. But here's the interesting bit. The mass of the helium nucleus is a tad less than the combined mass of the 4 hydrogen nuclei that created it. Where did this missing mass go, you may ask? Well, it didn't exactly disappear. According to Einstein's famous equation, E = mc squared, this mass has been converted into energy, a huge amount of energy. It's this energy that powers the stars, making them glow brightly in the night sky. Each second, the sun converts about 600 million tons of hydrogen into helium, and in the process, around 4 million tons of matter is transformed into energy. That's quite a feast being cooked up, isn't it? This energy radiates outwards from the core, eventually reaching the star's surface, and then it embarks on a journey across the vast expanse of space. Some of this starlight, after traveling for years, reaches our planet, providing us with daylight and warmth. So the next time you look up at the night sky, remember the fantastic fusion reactions happening in the heart of each star, cooking up a banquet of energy that lights up the universe. This energy, produced by fusion, is what powers the stars and makes them shine. However, the fusion of hydrogen to helium is not the only dish on the menu. Stars, those cosmic kitchens, are cooking up a variety of reactions, each contributing to their radiant energy. To understand this, let's look beyond hydrogen and helium. What happens when a star exhausts its hydrogen supply? Does it simply fizzle out? Not quite. Stars are resourceful chefs, and when the hydrogen starts running low, they move on to the next ingredient, helium. Helium, denser than hydrogen, requires higher temperatures for fusion. When these temperatures are reached, stars begin a process known as helium burning. In this reaction, 3 helium nuclei come together to form a carbon nucleus. This process, also known as a triple alpha process, is a star's way of saying, out of hydrogen, no problem. But the stellar cuisine doesn't stop there. When stars are hefty enough, they can fuse carbon into even heavier elements. For instance, in a reaction similar to the triple alpha process, carbon can fuse with another helium nucleus to form oxygen. These reactions from helium burning to carbon and oxygen fusion all contribute to a star's energy production. Each fusion process releases energy, lighting up the star and keeping it shining. This energy is so immense that it counteracts the crushing force of gravity, preventing the star from collapsing onto itself. But this is not a one-size-fits-all kind of deal. Different stars have different menus depending on their mass. Smaller stars, for instance, might stop at helium burning, while larger stars can cook up a whole array of elements, from carbon and oxygen to iron. It's a cosmic buffet, with each star preparing its unique blend of nuclear reactions. These reactions hold the answers to the luminosity and lifespan of stars, and they're also the reason why we're here today. After all, every atom in our bodies was once cooked up in the heart of a star. So, the star's menu is diverse, cooking up different reactions to power itself. Let's take a moment to summarize our journey into the heart of a star. We've traversed the cosmic kitchen, where the main ingredient is nothing but hydrogen, the most abundant element in the universe. Here in the searing depths of a star, hydrogen atoms are squeezed under immense pressure and temperature, so intense that they start to fuse together, forming a heavier element, helium. This process, known as nuclear fusion, is the primary source of a star's energy. It is an exothermic reaction, meaning it releases energy in the form of light and heat. This is the radiant energy that makes stars shine, the very same light that travels across vast cosmic distances to twinkle in our night sky. But this fusion reaction doesn't stop at helium. As stars age and exhaust their hydrogen supply, they start fusing helium into even heavier elements like carbon, oxygen, and all the way up to iron. This chain of reactions, often referred to as stellar nucleosynthesis, is responsible for creating most of the chemical elements in the universe, including the ones that make up our bodies. In essence, we're all made of star stuff. However, not all stars are created equal. Depending on their mass, stars can have different fusion reactions happening in their cores. For instance, our Sun primarily fuses hydrogen into helium, while more massive stars can undergo a series of complex reactions, fusing heavier elements at their cores. This diversity in stellar reactions contributes to the rich chemical complexity of our universe. So there we have it. The stars, these celestial furnaces, are not just beautiful spectacles in the night sky. They are cosmic factories, tirelessly cooking up energy and elements through nuclear reactions. The twinkling lights we see are the silent testament of these profound processes happening millions of miles away. Next time you gaze at the stars, remember, each twinkling light is a result of a cosmic kitchen cooking up energy through nuclear reactions.